All right. Today we are talking about GPT-4 Vision is a generalist web agent if grounded. And this is sort of a follow-up to the Mind-to-Web paper, and it's extended by implementing the agent that uses GPT-4 Vision. The previous agent was just using text, this one is using vision. So that's cool. Just to remind you, the setup with Mind-to-Web is that they created this data set where we have website snapshots and high-level tasks, and the sort of golden path solutions, how to complete this high-level task on this website. And that's a nice data set because then we can evaluate whether our agent implementation works well across many different websites and many different tasks. So in that original paper, they implemented an agent using just text. Here, this is a follow-up where the new agent implementation uses vision as well to complete those tasks. And the summary is that this is a pretty difficult task. So in the absolute best case, where half of the system is an oracle, which means a human that does the right thing based on judgment, in this best case, we're solving half of the tasks. So it's still a difficult problem to solve. Not to knock the paper, I think it's great that it's been published and that we know about it. It's just good to know that this is a difficult problem. So what this paper proposes is that given a website and a high-level task, we need to, at each step, kind of do two things and to be able to complete the task. The first thing is planning, and the second thing is execution or grounding. So planning is on a high level, given the high-level task and the screen and everything we've done until now, what is the next thing we should do? So like click on this button or fill in that field or like scroll down or whatever. Actually, I think they'll support scrolling. So like click, type, and then something else. So that's planning. And the second part is grounding. So given this plan, and the plan is literally plain text saying, click on such button, then grounding is the act of taking that and turning it into something that can be executed. So it could be, using Playwright or something, get the DOM selector of the thing you need to click on and click on it, or, XY coordinates on the screen or something, some concrete way of executing this given action. And they find that GPT-4 Vision is pretty good at the first part and pretty terrible at the second part. So pretty good at the first part means that if you replace the second part with an oracle, so literally a human that takes the descriptions, look at the DOM and finds the right DOM thing to interact with, if you replace this part with the human, then we complete 50% of the tasks successfully. So pretty good means, we still fail for half of the time. But so, let's say that's fine. We can somehow live with that. But the grounding is really challenging. So if we don't use the human oracle, they propose 3 different ways of grounding, and none of them work particularly well. So it's basically an interesting area of research. So the 3 different ways of grounding is, one is grounding by element attributes, where we're basically asking the LLM based on the image to predict what kind of DOM attributes the element we want to interact with has. And I'm not surprised it doesn't work well, because that would be difficult for like an expert human, web developer to predict. Who knows how things are implemented based on their appearance. The second thing is grounding via textual choices. So if you have a button with some text on it, you can find button with that text, and that works well as long as you actually have a button on the text and it's not like an icon. And also if the text is unique. If none of those are true, then this is going to be tricky. And finally, there's grounding via image annotation, where we basically give the image to ChatGPT Vision with some bounding boxes drawn over different elements, and each bounding box is annotated with some label, and we ask ChatGPT to tell us which thing to interact with. So it has a bunch of choices, and it gives us answers what to interact with. And yeah, none of those methods work particularly well. So in the end, they basically did all the experiments using the Oracle approach. And that's fine. It's interesting, but yeah, it's not easy to make it work. And this is basically the paper. The results are here. So they have per step success rate, but I think that the more interesting one is the per task success rate. So you can see the highest one here is 51%, and that's with the Oracle grounding method. And online means that this is like they're evaluating live websites. So they've done part of their evaluation on Mind2Web and part on live websites.